Hello, today we are going to look at how we can able to use the Pascal's triangle patterns together with a binomial theorem to operate on a binomial to make it more faster. But before we get into that, let's do one example without using the Pascal's. So here, if we have x plus 2 all squared, it's telling us that x plus 2 is multiplying itself twice. And if that is the case, in the normal sense, we would have taken this and then we multiply it to this. Bring our plus, take our 2 and we multiply again with that. Distribute this to that and this to that, and we distribute this and that. This become like terms. Put it together, we get that. We are done. But in our next examples, we are going to use a binomial to see how fast it's going to be, and even when this becomes so big, if it is like 3, and then you're doing this 3 times, realize that it could be a little bit tedious. If it is like 3 here, it could be tedious. And what about if it is 5? It's going to be more hard for us to do it. And that's the reason why we need to learn how to use the Pascal's triangle patterns together with the binomial to work on. So here, when we talk about the Pascal's triangle, it's going to help us to get the coefficients, which is these numbers that will be standing here. And then the binomial is also giving us the idea that's happening with the terms, the 2 terms that we will have here. So let's start with the Pascal's. So we start with 1, and then so that is of 0 degree. When we have 0 degree, we got that. The degrees are going to be this one. So this is 2nd degree. So when we have at the degree of 1, we split this one. What are the 2 directions that this can go? Is 1 and 1. So here, as we said, that we got so we started with 1, and then we add these 2 together. 1 plus 1, we get 2. We write it in the middle here, and then we bring the 1 here. This is of the 2nd degree. When we are raised to the power 3 or cubic, this is of the 3rd degree. Then 1 come here, and then we add this to this. We get 3. We write it in the middle here, and then we add this to that. We get also 3, and then we bring the 1 here. So that's how the Pascal's work. Now let's use the Pascal's here to do this here, which of the 2nd degree. Okay, couple with this binomial. Right. So here we are writing the binomial. So the x is for the a. So here x is for the a, and here we are saying that that one is going to take off the power 2 minus 0, because we are starting, when we are doing the summation, it's starting from 0. So 2 minus 0 is going to be 2, and then the 2 will take 0. Okay, and then we write plus the x again. The x is going to reduce by 1, so it's going to be 1, and then the 2 will take the 1. They are always adding up to the power here. And then the last one, because we're supposed to get 3 terms. This is going to be the coefficient. I'm about to write the coefficient. This will be, x will be 0, and then the 2 will take the 2. Now we need to write this coefficients. The Pascals give us the coefficient. So here it's going to multiply the whole of this. It's going to multiply by 1. And here the whole of this is going to multiply by 2. And the last one is going to multiply by 1. Okay, so here we got 1 times x squared times 2 to the power 0. 2 to the power 0 is 1. So here we got x squared. And here we got 2 times x times 2, which make it 4. And then the last one, we get 1 times x to the power 0. Any number or any variable to the power 0 is 1. So it's going to be 1. 1 times 1 times 2 squared. 2 squared is 4. So here we got 4. And we are done. So you see how easy it is as we get familiar a little shorter time. So that's how we use this Pascals to do that with a third degree of 3. So that means we're going to use this here. Okay, so now we're going to make it much faster. So we write the coefficients, which is 1, 3, 3, 1. And we know that the first term take all of it. So times x to 3. And it's positive, so we bring the positive. Now we are here. We realize that this will reduce by 1. So it's going to be x squared. And this will take the 1 times, this is my multiplication, times 2. We bring our plus. And here, since here is 2, now it's reducing 1. It's going to be just 1. And then this will pick the 2. So here times 2 to the power 2 plus, now this will have none because I have exhausted it, and this will pick all the 3. So times 2 to the power 3. So 1 times x cubed give us x cubed. 3 times 2 give us 6. We'll bring our variable, which is x squared. Here 2 squared is 4. So it's going to be 4 times 3, which is 12. And we bring our x plus 2 cubed, which is 2 times 2, 4 times 2, which is 8. Okay, let's look at this example whereby we have, this is a term altogether, but there are 2 of it. So 2x plus 3 to the power cubed is the same degree of 3. So we are using that coefficient, using the coefficient 1, 3, 3, 1. But here, this is together as 1. So here times 2x will take all the 3. This one is coming as a combo, so it's 3. And then this will have none, so we bring our plus here. Here, the 2x will reduce to 2. And then times the 3 here, and then times the 3 here, so times 3. We bring plus here, it will be just reduced as just 2x to the power 1 times the 3. We'll pick the 2, and the 3 will take all of it. So here, realize that it's just going to be 1 times 2 to the power 3, which is 8, and x to the power 3, which is x cubed. Plus, here we got a 3, 2 squared, 4, and then times 3, and then the x squared will come, plus 3 times 2 times 9 times x plus 3 times 3 times 3, which give us 8x cubed, plus multiply this 3 times 4, which is 12 times 3, which is 36, x squared, plus 3 times 2, which is 6, times 9 is going to be 54, x here, and then 3 times 3, 9 times 3, which is 27. So if we have been given to the power 5, it's multiplying itself 5 times. Here we stop at degree 3, so we have to make our way to 5 degree. So here we will bring our 1 here. This is a 4th degree, and we will add this 2, we get 4, we put it in the middle. We add this, we get 6, we put it in the middle. We add this, we get 4, and we bring 1. And then the 5th degree, we will put our 1. We add this, we get 5. We add 4 and 6, that give us 10. 6 and 4, that give us another 10. 4 and 1, that give us 5, and we bring our 1. So here we are using 1, 5, 10, 10, 5, 1 as the coefficients. And then here the A will take all the 5, you bring your plus. The A will take 4, and B will take 1, bring your plus. A will take 3, B will take 2, bring your plus. Here A will take 2, B will take 3, you bring your plus. A will take 1, B will take 4, you bring your plus, and B will take all. And that will give us A to the power of 5 plus 5A 4B plus 10 A cubed B squared plus 10 A squared B cubed plus B to the power of 5. And we are done. So here we see that the shape is looking like a triangle. That's how we call it the Pascal triangle. Please subscribe and see you in the next video.